today's demonstration, I'm going to work through a simple fraud use case. We'll use some data to build a model, and then we'll use the model to do some predictions, and then we'll talk about how you can operationalize all of that. Having said that, I'm going to switch over to my RapidMiner Studio client here and start the demonstration. We'll start on a clean slate here. Before I jump in, I do want to highlight a few things. A RapidMiner as a platform comes enabled with a lot of self-learning tools. We have a large user-based community. As you'll notice, every time you launch the platform, it lets you learn. It shows you a lot of training material for getting started. There are inbuilt tutorials as well as inbuilt templates that you can use to start your work on. For now, we'll actually use a blank process or start on a clean slate and go from there. What you're looking at right now is the RapidMiner Studio client. And for now, we'll focus on a few aspects of the Studio client. We'll be looking at what we call as operators. These are typically aligned here in the left corner that I'm highlighting. Using the operators, we'll build some sort of workflow in the center here, in this white canvas area. And each of these operators, when you're using them, you are able to configure here on the right using the parameters section. These are the three key areas that we'll be focusing for today. So our first step, obviously, in any data science project is to understand the data. And to do that, first we need to get the data to RapidMiner. RapidMiner provides several different variety of data access methods. A very common one is to read data from a database. To do that, I'm going to use an operator called as a read database. And as I highlighted, you'll notice RapidMiner prompts me to drop it in the canvas area, which I'm going to do right away. Once I've dropped the operator in the center canvas area, my parameters on the right are now contextual to the read database operator, and I'm going to say where I'm going to get the data from. So for now, I'll use a predefined connection. We'll pick one of my connections, or I could go ahead and define new connections. In this case, I'm going to build a very simple query, but RapidMiner has the ability to pull data from complex SQL files or tables directly. But we'll hit on the Build SQL Query button here. And RapidMiner gives you a list of the tables and views that are available. For today, we'll pick the data that is in the fraud training column. And for now, I think I'll use every column except the ID column. This is the index column that I pretty much don't want to use in my data science project today. But by hitting OK, I've configured the read database operator, and by connecting the output port to the RES, I have created the most simple process here, that is read the data and show me the results. To run this process, all I have to really do is hit the play button at the very top that is available here, and RapidMiner goes ahead and executes that process, gets the data out, and shows you the actual result set here. You'll notice on the left side here we have a bunch of additional things available. So the data view obviously gives you the raw data itself, but if I switch over to my statistics, RapidMiner neatly summarizes the data for you. So it's giving you an overview of what are the different columns available, their data types, if there are any missing values, and a bunch of statistics, right? So right off the bat, I know what kind of data I'm working with, and I can in fact try to find some insights here. For example, let's say I was looking at the number of international transactions column. As you can imagine, a number of transactions can be 0 or positive, and I see a negative value here. So obviously know there is at least one problem in my data where the number of international transactions seems to be wrong. The statistics help, obviously. I could also click on individual chart, rows and columns here, and as you notice, RapidMiner is giving you a good distribution chart. I could click on the open chart button to start visualizing the data in a variety of graphical formats. So this gives you the ability to start making sense of your data. And obviously, as you see patterns or as you see problems with the data, we can now go back and fix those and take corrective actions on those. So I'll switch back using the tabs at the top here. I'm going to click on my design tab. That takes us back to the design interface we were in. And if you remember, we had one problem, which was the number of international transactions were negative in some cases. So let's say for now I need to get rid of those rows. RapidMiner is an operator for data cleansing and data blending. There are several dozens of those. For now, I'm going to search for an operator called as filter, which lets me filter out data. I will bring it in the pipeline, and then as we did previously, I'll configure. So in this case, I'm going to use a custom filter, and we'll add a quick filter here saying my number of transactions have to be greater than or equal to 0. So by doing this, I have taken one corrective action in the data set that is coming in, that is filter out any rows that are less than 0. I'll quickly run this process again to make sure we are doing the right thing. And to verify that, I'll switch over to the statistics tab. And this time you'll notice the number of international transactions have dropped down to 0. So we have taken care of that one data issue. In a similar fashion, RapidMiner provides hundreds of operators around data preparation. So your things like you need to aggregate your data, you need to pivot your data, you need to sort your data, you need to do joins, unions. All of those are available in a single interface here. By dragging and dropping into the pipeline, you can build a really complex ETL workflow and then use that to deliver the data either to your modeling projects or even for your dashboarding projects. For now, we'll focus on modeling, and I'll keep continuing to build on what we have done so far. So I have got the data. I have taken care of my data problem, at least the one that I know here. So the next thing we are going to do is try to build a predictive model. To do that, we'll quickly see what's in the data so we can build a predictive model on. I have a customer ID column that describes or rather uniquely identifies each customer. Every row in here is one customer. I have used RapidMiner to summarize the data so I know for each customer the number of international transactions they have done, the gender, state, and so on and so forth. In real world, you'll have hundreds of these dimensions, and RapidMiner can help you put them in the right shape and form, summarize them in a very easy to use drag and drop interface. I also know from historical information which of these customers had conducted fraud. So my fraud risk column classifies the data set into two groups. That is, true means that customer has potentially done a fraud in the past, and false means they have not. So our goal for today's demo is to build a predictive model so that I should be able to predict frauds in the future for customers who might have a similar set of dimensions, but I do not know whether they are fraud or not. So let's see how we can do that. Again, as before, we'll switch back to the design tab. And this time we'll start telling RapidMiner what is that we're trying to do. To do that, we'll use a RapidMiner operator called as setRole. And as you have been noticing, I'm searching for operators rather than finding them. After a few days or few hours of work, you'll be able to remember these names and use them regularly. But for now, I'm trying to predict my fraud risk column. So I'll say my fraud risk is my label. Label is a RapidMiner terminology for telling what is the target variable. I also had a customer ID in there, so I'm just going to make sure that that does not get used in the model, and it's also used as an ID rather. So I set up another role here. So by doing this step, I got the data, I cleaned up the data, then I told RapidMiner what is that I'm trying to predict. RapidMiner, in a similar fashion to what you have seen so far, provides hundreds of different learning models as drag and drop operators. So for example, if you wanted to do a decision tree, there are several versions that you can easily just drag and drop into the pipeline here and build a workflow. Just to give you an overview, we have hundreds of models that are custom implemented. We also have models that are coming from Weka library. We also support integration with R and Python. If you're working with Hadoop, we can leverage the Spark library. So the algorithms and the variety of algorithms that you can use is absolutely deepest and broadest compared to any other vendor out there. But for now, we'll pass on the data that is cleaned and prepared into a simple decision tree learner. I'll leave the defaults to whatever is here. But at some point, obviously, if you need to change them, RapidMiner comes to the rescue again. You'll notice that on many of the operators, there are these small green arrows. If I click on those, RapidMiner gives you an indication of how other users have configured those particular operators. So when you're looking at the maximal depth value and you're not sure what should be the value of the depth that you should try, RapidMiner recommends you should try something between 20 and 29. These numbers are based on what we call as wisdom of crowds. Out of our community of 400,000 users, if you decide to opt in, we can capture your usage, and based on that, we can recommend you how the product is used and how other users are using the product. For now, we'll just leave it to default, and run the process again to see what the model looks like. And there I go. RapidMiner quickly went through all the data and it found the pattern, and at this point it is showing you a graphical representation of the decision tree model. Our focus for today's demo is obviously not to go through this model, but for now we'll just assume it is good enough. Down the line I'll show you how you can validate the models and optimize the models, but for now let's assume that this model is good enough. So how do we use this model in your business applications? So the first thing we could do is use a RapidMiner operator called as store that will let you store a model in any of our central repository. RapidMiner provides an on-premise server software that you can share your models, your processes at, your users can collaborate with, you can run bigger, faster processes on bigger servers if needed, and then when you need to schedule things, RapidMiner server is going to be able to help you do all of that. For now, I'll store the model in one of these folders here by configuring the location. And if I run the process again, obviously the output of this process will be a model that is stored in this location. On the other side, I obviously need to use this model. To do that, we'll again start on a clean slate. I will drag in the model that we had. I'll show you another data set here. That is what we are trying to predict on. So similar to what we did before, we have columns describing a customer. We obviously do not know which of these 100 customers is conducting a fraud or not. So our goal is to apply the model that we just built on this data set to predict out of these 100 customers who are potentially conducting a fraud or not. So now that we know what the data set looks like, I'm going to drag it here. In this case, I'm pulling it from a RapidMiner repository. Earlier, I showed you how to get the data from a database. RapidMiner can get data from its own repository. It can get data from files. For now, we'll just get it from the sample we have here. And then we'll use a step called as apply mod that takes in two inputs. One of them is your model that I previously brought in, and the other one is the data set you want to score on. And the output of this process is going to be your final score data set. And to run this process, I'm going to quickly run it again. And as you notice here, RapidMiner quickly tells you that there is a problem with your data set. So I could obviously go ahead and fix this problem by taking care of that particular ID that has gone missing. But the idea here is RapidMiner is going to give you contextual hints and contextual information as you build this process, right? For now, rather than fixing this problem, I'm just going to open up a quick process that we have here and build on top of it again. So here I have a similar process. I get the data. I am building a model out of it using an optimization step, and then we'll apply the model. To run this process quickly and show you the output, we will wait till the circle completes. So RapidMiner gives you hints around how much time it is going to take, and the output has 3 new columns. So remember, from the data set we want to score, we did not know the fraud prediction obviously. RapidMiner gives those prediction columns, and then it gives you the confidence interval. So in this case I have 2 classes, so it tells me the fraud classes and the confidences for each of those. So if I now sort it by decreasing order, my customers in the decreasing order are more potentially conducting a fraud. So at the end of this process, obviously knowing which customer is going to conduct a fraud or not is helpful, but we need to deliver this results back to our business applications. To do that, RapidMiner makes it very easy. You could do things like, I want to generate a dashboard out of it. So you could bring in an operator like Tableau extract operator, or maybe a ClickView extract operator that will let you write out the results to a Tableau or a ClickView extract file. If you really want to push this out to your CRM systems like Salesforce, there are abilities in RapidMiner to connect to various business applications, Salesforce being one of them. So now I could go ahead and bring in a Salesforce write operator, configure it on the right where it should write it to, and now the predictions are written directly to this application. And a very generic one, which is write to a database, would let you write out to any of your custom applications. We also support writing out to various formats like CSVs, Excel, so that you can interchange the output with a variety of different applications. Obviously, so far what we have done, we have been triggering the processes using the play button here. If I need to run this on a bigger, faster machine, the same process that you build on your desktop can be easily executed on a server by just simply expanding on the options and clicking on running process on the server. So I could build a process on my desktop and then let it run on, millions of rows of data on a bigger server somewhere if needed. Also, as a data scientist, once the process is built and once the model building process is in place, you have the ability to schedule the process on server. RapidMiner provides a very flexible inbuilt scheduler on the server where you have the ability to define how often the server should run that particular process, and it could go as low as every second, every minute, every hour. So right from within the same platform, you're not only building a model building process, you're building a scoring process. You're able to write those outputs to your business applications and then deliver those results directly into that business application at a predefined schedule. That is obviously helpful in cases like where doing things on a regular basis is good. But for the use case we are talking about today, a use case like fraud detection, the real value is if you can stop a fraud while it is happening. So running this process on a scheduled basis at midnight is not going to be helpful. So RapidMiner actually provides the ability to run these processes in real time. RapidMiner server provides the capability to convert any of these processes into a web service. To do that, all I have to really do is right-click on a process and hit browse. That will take you to our server interface where you'll click a couple of options and convert any process into a web service. That web service can take in inputs and deliver output back in various formats like XML and JSON, thereby allowing you to integrate a sophisticated data model, sophisticated scoring model into any business applications with utmost ease without having to write a line of code. We'll skip that part for today, but the idea is everything that the data science team builds can be made available to business applications, can be operationalized in business applications in a matter of few clicks. Having said that, we went through the whole life cycle of get the data, clean up the data, build a model, and obviously deploy the model. Obviously, a very critical phase of your data science project is to understand how good or bad the models are. RapidMiner, once again, provides a very intuitive way to do that. RapidMiner provides a variety of validation techniques in a similar drag and drop fashion. So some of the most common techniques that are needed for data or model validation are available as drag and drop. To see one of those in actions, I'm going to use one of pre-built processes. Over here, I have the same steps that we did earlier. Get the data, we'll clean out some of the problems we had. I'm going to tell what is that I'm trying to predict. And then, instead of connecting directly to a decision tree operator, I put a validation operator. I'm using the cross-validation operator here. And I tell RapidMiner will do 10 iterations, so it is going to do 10-fold cross-validation. If I double-click, I have the training part and the testing part. So on the training part, we're still going to use a decision tree. And on the testing part, we're going to capture some performances. RapidMiner automatically splits the data in different samples based on how you configured this one. So in this case, I'm going to use stratified sampling. And if I run this process, RapidMiner does a 10-fold cross-validation, comes back with a model, but also delivers me the performance. So in this case, RapidMiner model is 82% accurate, and I could obviously go to the other vectors that are captured here to see how good or bad the model is. If I need to iterate over this, instead of, let's say, a decision tree, I want to use a KNN or a SVM or a neural net, all I have to really do is drop in a new operator and remove the previous one. That lets me quickly iterate over different models, different combinations, and go from there. RapidMiner also provides an automatic way to compare and contrast different models. So that is always a possibility, but for now, you could easily switch over one or more of the operators and reuse the processes that you have built. The other aspect of modeling is, while validation we saw, we are able to get around 82% accuracy. But if you go back to your decision tree, there are so many different parameters that can impact your model, that can improve or decrease the performance of your models. So a lot of time data scientists have to give an error and trial to these values to see how the model behaves when the value is at a 30 or 40 or 70, and then come back to a value that will work best. Instead of doing that guesswork, RapidMiner actually provides a variety of optimization techniques. One of the most commonly used optimization techniques is the optimized parameters grid. What that lets you do is I could bring in an optimized parameters grid operator in the pipeline, and I will use my validation step, cut it, and paste it inside. What RapidMiner does here is lets you optimize parameters, and the way to configure that is if you go to the settings, you can see that RapidMiner just discovered all the different operators that are inside. We had a validation, and then inside of that we had decision tree and a couple of other operators. So I can now select any of these operator parameters. So for a decision tree, let's say I want to try depth, and I can tell RapidMiner try between 20 and 100 in 10 steps. So RapidMiner actually goes ahead and builds models at these values. At the end of the day, it would have built 11 different models for this one parameter. And then it will actually deliver us not only the best model, but tell you where it got the best values. So to view those, I'm going to make a few more connections, and we'll quickly run this process. So RapidMiner now is running that optimization step. It actually built 11 different models here. This is the best model that came out of it. But if I quickly switch over to the parameter set, RapidMiner highlights that the best model came at a depth of 44, and the accuracy was around 84%. So from 82 point something, we went up to 84 by 37 just by using RapidMiner's optimization operators. In a similar fashion, you'll notice there are various other optimization techniques. If you're not sure which features contribute, we can use the optimized feature selection. If you just want to understand the influence of different features, RapidMiner provides a variety of weighing techniques. Again, all of this is possible with a simple, easy drag and drop interface. RapidMiner enables you to complete the whole life cycle of your predictive analytics cycle in a very self-service manner. We enable lightning fast data science, and then when it comes to operationalizing this, as I mentioned, every process that you build with RapidMiner can be scheduled to run at any frequency. Any process can be converted into web services that you can integrate with any other application. And RapidMiner on top of it provides a lot more functionality compared to most of the vendors out there. We have the ability to do unstructured data mining. We have the ability to do Hadoop-based processing. So again, a very innovative open source platform that is used by hundreds and thousands of users across the globe in a variety of verticals.